Good afternoon or good evening, ladies and gentlemen. Thank you very much for having me. Thank you to the organizers of this event. I am Dmitry Koroteev. I work for Skoltech and Digital Petroleum. I'm going to talk about AI in oil and gas. People produce a lot of oil in the world, and they've been doing so for a long, long time. And the balance of hydrocarbons in the energy sector has not changed much over many years, although we see green technologies coming our way. But for a number of years, oil and gas will continue to play a big role. Without them, we cannot hope to live comfortably. It seems like all our oil and gas companies should be rich and happy. But that's not quite that way. Oil is difficult and expensive to produce. You can see that seismic work, exploration, geological research is very expensive. We're talking about dozens and hundreds of billions of rubles, especially if companies have to put ground infrastructure in place. That impacts the cost of production. In Russia, it amounts to about $20 per barrel. This includes capital investment. This includes lifting cost and transportation. When prices stay in the band of $40 per barrel, that raises a serious concern over the profitability of operations. There are several areas where artificial intelligence can be used. First of all, it is important in exploration to save money in this phase. We also can get rid of redundant operations so that we can start producing oil sooner. And it is also essential to make objective, precise forecasts and reduce risks. It helps us to get away from a situation when two experts have three different opinions. In the last 3 years, AI penetrated into oil and gas industry quite broadly. We have seen a number of pilot projects based on AI, and we see some big projects, serious large-scale software solutions are designed and built for oil and gas companies and service companies, and they are put in production. We see a pipeline of products. You can see them in this chart. First of all, we need to understand the challenges we need to address. We need to have a team that would be collaborative, that would be willing to find new creative ways and solutions. Then we have to have a description of an architecture and an approach. We have a concept. When the concept is ready, they build software code and a compute core. This gives us a prototype that can be tested. We can feed real data to this prototype and see whether this solution is going to increase our effectiveness. When we add everything up, we can say that we have a ready product that we can deploy and that we can start using in everyday work to address the tasks that we set for ourselves in the first place. Today, I see four major paths that AI products take from the initial idea to industrial application. Path one starts when the industry generates an idea. Then some group of researchers would get a mission. They would create a prototype and then they would pass it over to the customer along with the intellectual property rights. Normally, this means that the product would become proprietary and it would never see the rest of the world. If the prototype does not fly very successfully, it may never get used extensively. The compute cores, though, can be trained very well. The second path is when R&D organizations come up with an idea and they throw it at the industry. If the industry likes it, then it can come up with some cash to pay for this research. And in the end, there will be a piece of intellectual property that usually a customer would own. In most situations, this is the most popular path, and there is a risk that once the intellectual property rights end up with the customer company, this product is not going to see the rest of the market. There is a third path, which I could call a bit pragmatic. R&D people in a university or in a company would create an idea, develop it, own the intellectual property rights, and then they would sell it in the market. Then there is a fourth path when R&D organization would create intellectual property, and then they would set up a new company, build a product, and they would market a product in the open market, and they are not dependent on any specific customer. This is kind of a Western paradigm of product development, and this would be my preference. As of myself and my company, we try to live in this paradigm. It is wonderful when you can make a product that can be marketed to more than one customer. Artificial intelligence has proven to be working well in oil and gas. We see the experience of people who work with me. I can tell you from my own experience that we have saved about 10% of costs associated with building horizontal bore wells. We have reduced downtime at the construction period. We have been able to achieve a 40% reduction in the cost of geophysical research and core sample examinations. We have accelerated by a million times the routine work on the core sample data. We have helped to create simulations of various reservoirs, which were very helpful in acceleration of the actual production. One of our prototypes allowed to reduce the time for building of a petrophysical model from 1 week to 2 seconds, which was very, very cool, because in the end, an oil company had clear understanding of what it could do with the reservoir. They knew where to start drilling and how they could lift oil in production. I can show you a couple of the AI products. This is a product that we call Conformal Predictor. We are launching it in the market as we speak. It is designed to evaluate an oil field over just a couple of minutes using inputs from oil field description. It does not conduct classic long geological studies that may take up to 2 years. Artificial intelligence would do a first evaluation in only a few minutes. This is another product known as DeepCore. It would provide a million-time acceleration in the work of a petrophysicist. This is an engineer who would examine core samples, identify different types of rock at different depths, and make predictions about availability of oil in different reservoirs at different depths. DeepCore would address this task a million times faster. In just a few minutes, they would conduct a typization over a large volume of core sample material. These are rocks that one finds deep underground where the oil is. Where AI technologies are going in oil and gas industry, I believe there are four main areas. First of all, we need to see what we can do to develop platforms with different heterogeneous types of data with full-scale semantic layers. It should use machine learning mathematical optimization to understand where the data is to run these algorithms. It is very important to see the development of forecasting operating systems, what people call a strong AI. These are systems that can learn by using a fairly small amount of data. We also need to look into smart planning and dispatch centers. We should see what we can do with them to optimize various complex chains, like building oil wells, like building logistic chains, like improving oil production from old reservoirs that have been in production for many years. It's also important to create universal data access channels, and the data should be available in standard forms, just like they do in OSDU consortium. Open Source Data Union. That's what this acronym stands for. When we have a clear pipeline of data access, we can test algorithms that we get from different sources. We can select the best stuff and put it in production at our customers. This was a quick overview of what goes on with AI in oil and gas industry. This gives you the big picture, and I really encourage you to listen to the next presentation from Sergei Safonov from Saudi Aramco and Aramco Innovations. He is going to focus on the biggest oil company and in the world and what it does in the way of using artificial intelligence. This is the end of my presentation. Thank you. This was very interesting. Indeed, we do have a few minutes for Q&A, but I am going to use the privilege of a moderator and first ask my question. Here it comes. It's a simple question indeed. We are talking about different industries today, and we have representatives from different verticals. Many people would have the following questions. The models, the algorithms that you described, they probably are unique in some way. Can they be scaled out to other industries? Is there a way to use them anywhere else? Maybe Rosatom can use some of your stuff, and would it be too difficult?
Да, безусловно, многие
Well, obviously, all of these algorithms, most of them are scalable. Rosatom has got quite a lot of geological attempts with the geological research carried out in a slightly different sphere. Yet, but some of the prototypes and algorithms completely match exactly with such studies, and we have unique solutions like solutions for drilling. They are very hardly scalable and movable because they have very narrow selection of features tied together. So I think this split is 50-50. The image recognition is a scalable thing, definitely. But some of them are not that easy to put across all of the industry.